This assignment in 7.3 is a review of 7.1 and 7.2, finding the probability of compound events and using the fundamental counting principle. So we're going to do one example from the first worksheet today, and then we'll do two from the second. So on the probability of compound events problem solving practice, let's look at number 2. So on number 2, it says coins. Lorelei tosses a coin 4 times. Draw a tree diagram showing the possible outcomes. What's the probability of getting at least 2 tails? So the first thing we need to do is figure out our tree diagram. So she's tossing a coin 4 times. So tossing a coin gives us 2 outcomes. It's either going to be heads or tails. But then we're repeating the process 4 times. So the first thing we're going to have is our 2 possibilities. So we have a possibility of heads. I'm going to put an H for heads and a T for tails. So that's the first time that we roll the or flip the coin. The second time we've got a heads. Now we can either get a heads again or a tails. And again, if we got tails the first time, we can get 2 choices, heads or tails. So this is the second time we flip our coin. Now the third time we flip our coin, we are going off of all of this second section of our tree. So the third time, again, we have heads or tails, heads or tails, heads or tails, and the last one is heads or tails. Okay, so that is 1, 2, 3 times that we flip the coin. So we have one more choice to go. So let's go ahead and write that in so we can get heads or tails again. Heads or tails. And we're going to continue filling in our chart. And we get heads or tails. Squeeze it in there. Heads or tails. It's going to get full. And heads and tails. So there's our tree diagram 1, 2, 3, 4 times that we are flipping that coin. Now the question asks us now, what is, see if I can find a different color here. What's the probability of getting at least 2 tails? So probability of getting at least 2 tails. Okay, so then let's go through and figure this out. So if we get 2 tails, now in this line here, we don't have any tails, so that's not going to work. Then let's follow this next one. When we get to here, we have 1 tail, and not that one, this one, tails. Okay, so we can follow this path here. That's one of them. The second one, if we go to tails, we have 1 tail here, then a heads, and we have to get 1 more tail, so it would be here. Or we get a tail, and we can either get now the heads, or we can get a 3rd tail. On the second part of this, the second tree, we get a tails to start with, so we just need 1 more. So we can go heads, heads, and we can't go heads here because we need 1 more. So we could go tails though, and we would have 2. And then 1, 2, we already have it, so we can get that one or this one. And then tails, tails, we already have 2. So now any of the outcomes after that would work. So it would be this one, this one, this one, and this one, since we already had 2 tails there. So to write the probability, you have to know how many choices out of your total. So looking at our total outcome, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the probability of 2 tails, tails, that should be now, tails, is out of 16, and then how many did we circle? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 out of 16 would be the probability of getting 2 tails. So let's go ahead and look at number 3 is going to deal with the same tree. So you're going to use number 2 to answer number 3. So I'm going to let you do those on your own. Let's go ahead and flip over and look at the second page today. Okay, our second page is the Fundamental Counting Principle Problem Solving Practice. 7.3b is what we labeled it. We're going to look at number 1 and 4 today to do together, and then we'll let you do the rest on your own for homework. So number 1, Trad owns 3 surfboards and 2 wetsuits. If he takes 1 surfboard and 1 wetsuit to the beach, how many different combinations can he choose? So we have 2 different things happening. We have surfboards and we have wetsuits. Okay, so it says that he owns 3 different surfboards. So the choices are 3 surfboards and he owns 2 wetsuits. So 2 wetsuits. So using the fundamental principle, we can multiply these 2 numbers together to give us our number of different combinations he can choose. So 2 times 3, or 3 times 2, is going to give us 6. So there are 6 choices that he has, or different combinations. Okay, as simple as that. Let's look at number 4. Restaurants. Margaret's favorite restaurant has 3 specials every day. There are 2 choices of vegetable and 3 choices of dessert. How many different meals could Margaret have if she chooses 1 special, 1 vegetable, and 1 dessert? So again, let's identify the different independent events. So we have 3 specials. So we have specials, and there are 3 of them. We have 2 choices of vegetables, so veggies. And we have 2 choices. And then dessert, we have 3 choices. Okay, so using the fundamental counting principle, we can multiply all of our different outcomes to find out how many different ones. So 3 times 2 times 3. So 3 times 2 gives us 6. 6 times 3 gives us what? 18. You're right. Okay, so 18. So 18 would be our answer. So go ahead and finish the rest of the problems for homework. If you have any questions, you can join your teacher's Zoom meeting, your math lab, to get some questions answered. All of these are pretty straightforward. Identify how many choices that you have on independent events, and then you're going to multiply them together.